All right. So the volume of a pyramid is given by the formula V equals 1/3 capital B capital H. Those letters still represent the same thing. It's the area of a base, whatever that area formula is for the base shape. And the capital H is the height of the solid for that. Now, again, looking at these, just because you can see that you can calculate volumes for both right and oblique solids, but remember, a right solid is one where the bases are directly above each other, or in this case, the vertex is right over the very center of the base. This would be an example of a right pyramid. The one that's not the case, where the vertex is directly over the center of the base, is called an oblique. Again, oblique means not right. And that's going to be true for any solids. So again, we'll review it when you see it. And so if you're looking to calculate the volume of a pyramid, the way that you would find that is you recognize the solid that you're dealing with. Anytime you're dealing with a pyramid and you're calculating the volume, it's 1/3 BH. You then find the area formula of its base shape. So here in this pyramid, it's a rectangular pyramid. So the base formula is B times H with the lowercase letters representing the length and width of that, times the height of the solid itself. And so now you plug in your measurement. So 25, your corresponding height of that rectangle, 12. And then the height of the solid, notice it's given here as this perpendicular from the vertex to that base of 7. And so this one fits nice and easily directly into the calculations. And if you perform the calculations for this, you get your answer to be 700. But I do recommend just use the calculation. It's much simpler and it shows your work. Now, volume, just like with the others, is a three-dimensional measurement. This one doesn't include the units, but it is cubic centimeters because volume's three-dimensional. Right, so I want you to try this second one here in the bottom left. See if you can calculate the total volume of that triangular pyramid. For whatever reason, through the past decades, triangular pyramids tend to be the formulas that students mess up on. Okay? And it's just because of the sort of stacking fractions to get what you're calculating. And so make sure you have some systematic process for looking at these. Okay? First, you're finding the volume. Okay? Next, you see it's a pyramid. So the volume formula for a pyramid is 1/3 capital B capital H. Again, you'll always see me write that form first before I start writing the individual formulas. And so it's here that a lot of times a student forgets to put the 1/3. Okay? So if you just start off right away with the triangle area, which is 1/2 base times height, I think what happens, and like if I'm justifying why this is the problem that students tend to miss, is you see that fraction, you see the 1/2 there, but if you haven't put the 1/3 in front, you just kind of think that you have your fraction form, and so you maybe miss that it requires two fractions, the 1/3 and then the 1/2 base times height, and then the capital H. Once you have all of this, then you can go in and write your, plug in your numerical values. So 1/2, the base of this triangle has one side of 5 and a perpendicular to that of 14. So you can use 5 and 14 as your base and height. And then the height of this whole, the whole pyramid here is 22. And so there's your calculation. Again, nice and easy. That's what you can enter. And if you are entering your answer as a calculation, you can go ahead and type it in. And when you do that, you get 256.67 approximately. And once again, you have a unit here of centimeters. Since we're dealing with volume, it's a cubic centimeter for the units. All right. So you'll also see questions where you're given the volume and you're asked to find some other missing piece, in this case the height of the solid, but it could be the length or the width of the base. But I want you to see if you can calculate what is the height of this pyramid given the volume. Right, so on this, again, even if you're finding a different measurement, we still begin with the volume formula. We have a pyramid, so it's 1/3 capital B, capital H. Our base is a rectangle, so it's 1/3 times base times height times the height of the solid. And now I'm going to plug in the pieces that I know. I'm given a volume, so 1840 is on the left side. 1/3 times my base is 48. My height is 23. And that's all times my H value. And I'm going to go ahead and call this X since it gave me an X for that. So I'm going to solve for X here. Now, if you wanted to, you could simplify. 3 does go into 48, but we can also just divide by this whole quantity. It makes it nice and easy and clean. So all of those cancel, and you're left with X. And so once again, you can enter a complex fraction, meaning a fraction within a fraction. If you entered this on your MyOpenMath entry, it would mark it as being correct. Okay, and here, if we type this whole thing in, notice even in Desmos, we can still do that same thing. That whole 38 winds up is fine, being put inside what you have. Now, most likely, you should get a integer value for these, okay, just as kind of a hint or a clue. If you don't, double check your calculations and make sure that you're doing things correctly. Now, if the volume is given as a decimal, as it might be in the case of a cone, okay, then maybe you don't have an integer value, but it's likely going to be an integer height. All right, so that's a pyramid finding the volume. The volume of a cone, just like how cylinders and prisms have the same volume formula, the same is going to be true for cones. With pyramids, it's still the exact same formula, and that formula is the volume is equal to 1/3 capital B, capital H. Now, just like with cylinders, a cone is there's only one base shape that could possibly exist for a cone, and that's a circle. So we can replace capital B with pi r squared. And so this would be our more precise formula to use for this. Okay, so if we were looking to solve this particular question, okay, I want you to, let's look at this one first here. So if we look at this problem right here, we see that we're dealing with a cone and finding its volume. So 1/3 capital B, capital H, where the base is a circle, pi r squared. And so if we plug in what we have right here, our radius is given as 9. Our height was given as 22. Look carefully at the arrows, because notice the number 22 kind of seems like it's on the hypotenuse, right? Or on that, it's called a slant height. Okay, but it's not. The arrow points to that vertical, that perpendicular. So that is the height. Therefore, this is your calculation. And when you type that in, again, you are going to have pi in your answer. Okay, and so you get this answer here of 1,866.11. The units are centimeters. We're talking about a volume, so it's cubic centimeters for the units on that. But you can leave your answer as the calculation. All right, there will be times that you have to do some other manipulations to get the measurements required for the formula. And so try this second problem here to the right. See if you can find what's the volume of that cone with a diameter of 24. And this is called a slant height. And a slant height is designated with an L. All right, so again, you find you're dealing with a volume. Read carefully, is it asking for volume or surface area? In homework, they're grouped together, but on a quiz or a test, they're not. They're randomly distributed. So you need to read it carefully. So the volume formula for a cone is 1/3 capital B, capital H, where the base is always a circle, so pi r squared. And when you plug in your pieces, here they give you the diameter, which means the radius is going to be half of that. So 12 squared. And the height, notice here, if this is 12, you have this right triangle, hypotenuse. The slant height is the hypotenuse of that corresponding right triangle. And so you can find what the height is here. This is capital H by either using Pythagorean theorem. So we could say that h squared plus 12 squared equals 20 squared. Subtract 12 squared and extract your root. Or you could try to build it from a common triple. So 20 is 4 times 5. 12 is 3, or 4 times 3. Therefore, the height is 4 times 4, right? It's a 3, 4, 5 common triple with a multiplier of 4. And so the height's going to be 16. That prevents you from having to do any calculating. You can enter your answer just like this. And if you do enter a calculation, you have 12 squared times 16. And you get your answer to be 2,412.74 approximately. Again, units aren't included on this, but it's centimeters cubed since it's a volume and a three-dimensional measurement. All right, so once again, when you're looking at a slant height, if you have a right triangle that you rotate about one of its legs to form the cone, okay, the one leg of your triangle is the radius. One leg of your triangle is the capital H, the height of the solid. And then the hypotenuse of your right triangle is the slant height. Okay, so be aware of those, where those measurements come from when you are doing the solid of rotation. Okay, and see if you can answer this last question on this slide, kind of following that same guideline. Okay, so you have a right angle, or a right triangle with a base leg of 22 and a height leg of 9, and it says it's rotated about its height leg. So that means here's where the axis of rotation occurs. Okay, and so here's the cone kind of represented as the rotation. So 22 is our radius, 9 is our height, and that would make this our slant height, which we don't specifically need in this problem, but that's where that would be located. And so when you set up and calculate your volume is 1/3 BH. Again, just like with the pyramids, missing out or forgetting the 1/3 is a common mistake made for cones as well. So make sure that you're aware of that. The base shape is always a circle. And so if we plug in what we have here, a radius of 22, the corresponding height of 9, and that will give us our calculation. If you're entering your answer in the calculated form, just type it in. Oops. And that would give you your solution here, 4,561.59 approximately. The units are millimeters. Volume is a three-dimensional measurement. And so those would be your answers. All right. So these are the volume calculations that you need to be familiar with. Okay, before I get to the surface area, and the surface area formula that you need to know for these is just going to be for the cone. I'm not going to go through the surface area for pyramids. If you happen to see a problem where it asks for the surface area of a pyramid, just find each of the sides separately and add them together. Okay, but before we get to the surface area, there's one last thing. Again, we talked about it with the cylinders and prisms. Okay, and so this is the same instance, right? When you have two similar figures or solids, the ratio of their parts is m to n. The ratio of their two-dimensional measurements, like area, are m squared to n squared. And the ratio of their three-dimensional measurements, like volume, are going to be m cubed to n cubed. And so those are your the similarity and the ratios. Okay, and so I want you to try to solve the similar problems as what you saw yesterday, but this time using pyramids and cones. So see if you can find what's the volume of pyramid B based on the corresponding pieces that you see between these two similar pyramids. For all of these types of problems, you take what is the ratios that you know. So here in this, it says that we have the ratio of two corresponding heights. Heights are one-dimensional parts. So the ratio of heights are 7 to 2 or 2 to 7. It really doesn't matter the order you put them because you're going to rearrange them anyway, depending on whether you're moving from big to small or small to big. And then figure out what you're trying to find. We're trying to find volumes. So we're moving all the way from ratio of parts to ratio of volumes. So we're going to take this ratio of 7 to 2 and we're going to take it to whatever power represents the dimensions of our measurement. So volumes are three-dimensional. So I'm going to test what is 7 cubed. That's 343. And 2 cubed is 8. And so this is going to lead to a conversion factor. Now, it has two possible conversion factors. Okay? And it's just the two different rational forms or fractional forms of these. And what we see is this first one would be used if we're going from small to big because it's greater than 1. The second conversion factor would be used if we're going from big to small because it's a number that's less than 1. So here we know the volume of the bigger one. We start with that volume, 168, and we're going to multiply it by the number that makes it smaller. So the one that makes it smaller is the number that's below or less than 1. So 8 over 343, and that's going to be your calculation for this. We get our answer of 3.92. And that would be the volume of that smaller pyramid. Right, if we're doing the second one, same idea. I'll just kind of walk through. But here you have these similar cones. This time they gave us the corresponding diameters. Diameters are still one-dimensional measurements, so the ratio of our parts is 4 to 11. And if we're calculating the new volume, the volume is going to be that ratio cubed. And so 4 cubed is 64. You should be familiar with that. 11 cubed is 1331. So your conversion factor is either 64 over 1331 or 1331 over 64, depending if you're making it bigger or smaller. And so if we start with the given volume, 90 pi, and we multiply by the conversion that goes from small to big. So small to big is this 1331 over 64. So there would be your answer if you leave it as a calculation. If you are putting this directly in as a decimal, you can type it and you would get 5,880.18. The units are feet and it's a volume, so it's cubic feet for that. So either the calculation or the calculated value would work. All right, so that's just a review of what you already saw with the cylinders and prisms. You'll randomly get questions that'll be one of those: a prism, a pyramid, a cone, or a cylinder when it comes time for your tests. All right, the final concept that we're going to look at today is surface area of a cone. We're not going to do surface areas of a pyramid. Okay, and there is a formula associated with this. Okay, and the calculation for this is just one that you kind of need to just memorize. Okay, and it is the net won't necessarily give you all of the information for this, but you do have your area of the base here. And then when you look at this, this slant height here is this measure, and then you have your the arc is this sector formed, but it's just given by the measurement of pi RL. Okay. And so that is your equation for the surface area of a cone, and this is one that you just need to be aware of, where the radius is r and L is the slant height. Again, the slant height is just the hypotenuse of a right triangle that was used to create that cone. So if we're looking at this first problem here, what's the total surface area? Surface area is pi r squared, the area of the circle, plus the lateral face, which is pi r L, and it's just a matter of plugging in what you have. The radius is 3, and the slant height in this particular case is given. Once again, look carefully. If they have an arrow pointing to the height, then that's the height. In this case, there's no arrow pointing to the height of that, so it's the slant height. And so here would be your calculation, or once again, if you are entering it as a calculation, you would get your answer to be 150.80. The units here would be inches. This is surface area is a two-dimensional measurement. And so again, I would suggest you just use your calculation, but the units do refer to square units for that. All right, I want you to try this last problem here. Again, this is it's indicative of what you would likely see that's a little more challenging or on the multiple steps to solve it. All right, so this problem says you're taking a right triangle with legs of 8 and 18, and you're rotating it about its longer leg. So that means 18 is the longer leg, 8 is the shorter one. Which means now as you rotate this around, it forms the cone. And so that's the surface area that you're trying to measure. It's pi r squared, the base, plus pi r L, the lateral surface. Okay, so here we see the radius is this measure, which was 8. And the slant height is this measure. Okay, now it may be given, and it may be something you need to calculate. In this instance, it's what we need to calculate. So on this problem, we would need to use Pythagorean theorem. 8 squared plus 18 squared equals, I'll call it L squared, and extract your root. And so this measure right here is actually what goes in this column. Okay, this is not a common triple. Okay, it's not something that you can find the solution for as an integer. And so you can just enter this as your calculation, pi times 8 squared. And then we add to that pi times 8 times the whole square root of that quantity, 8 squared plus 18 squared. Okay, and that gives you your solution here for this answer, 696.12. The units are yards. Surface area is a two-dimensional measurement. And so leaving your answer as a calculation is good, or you can calculate it out and write it in.